Okay, trig identities, solving equations and verifying values in equations. So verify that this equation is true for this value of x. So all we're going to do is plug this value in to the x location, and it's to verify that it's true. So when we're working out, we need to have an equal on both sides. So I'm just going to plug it in. That's the first step. Okay, now I'm going to have to find the trig values. So if you think about 5 pi over 6 on the unit circle, we're right there. So the coordinate on the unit circle, so obviously this is connected to the cos value and this is connected to the sine value. Okay, so cos is negative root 3 over 2, and then 1 minus the sine. So I'm just replacing that with its sine, with its trig value. 1 plus 1/2, and then, okay. So now you've plugged in the trig values, so now you just have to do your algebra. So negative root 3 over 2 divided by 1 minus 1/2, so that's 1/2. I'm going to switch this to multiply. So my final answer is negative root 3. And then here 1 plus 1/2 is 3/2. So now I'm going to switch and multiply. And those cancel, so 3 over negative root 3. Okay, I'm just going to rationalize the denominator, something you've learned in grade 11. So negative 3 root 3 over, that would be positive, and root 3 times root 3 is root 9, so that is a whole number 3. So those cancel, and now we have verified that it came out to the same. Okay, the next example here I have is simplify this expression to one of the 3 primary trig ratios. Okay, so sine 2x, so what I do is I go to my sheet and I look for something that I can replace. So sine 2x, that's the identity. So 2 sine x cos x over cos 2x. So I'm looking for something to replace it with. So I have 3 choices there. Okay, so I am going to be picking this one. So 2 cos squared x minus 1. And then I also have a plus 1. Okay, so I replace that, but then don't forget you still have the plus 1. Okay, so algebraically a minus 1 and a plus 1 would disappear. And then, so 2 sine x cos x. Now, since I have only things divided and times, I can cancel. So 2's cancels. 1 cos would cancel with one of those. So sine x over cos x is a simplified division, and we can say that that would be equivalent to 10. Okay, next. So for what value of x is the identity undefined? So you can never have 0 on the bottom of a fraction because you can't divide by 0. So we're going to factor this one. So 2 cos x, and then those need to make 3, and I need to have my OI combo of my FOIL make us negative 7. So I'm going to go 3 there and 1 there, so that I'm making a 6 and a 1 when I FOIL that out. Minus, minus. So 2 cos x minus 1 equals 0, cos x equals 3. And then in this one, it's also the same as cos x equals 3. So here, if I move everything over, cos x equals 1/2. So I don't want values for where an x value would make my cos become 1/2. And there actually is no value where this would exist anyway. There's no angle here, because you can't ever have above 1. So I don't want what value of x? So where does cos equal 1/2 on your unit circle? Okay, so that would be pi over 3 and 5 pi over 3. So x cannot be those angles. So if you tried to plug those into your equation, you would get an error, because in your computations you would have a 0 and then you'd be trying to divide by 0 and it wouldn't work. Okay, solve sine b equals sine 2b on this interval. Okay, so sine 2b, I would go to my trig sheet and I would replace that. So sine b equals 2 sine b cos b. Okay, and obviously just whatever variable you have, that's what I'm replacing. So first thing is to figure out the trig identity to replace. Now think of your strategies to solve this. So I am going to move this over, because our strategies from at 11 are kind of move everything to one side and try to factor. So 0 sine 2 sine b cos b, and then minus the sine b. Okay, so now when I try to solve this, I'm going to factor. And remember all your styles of factoring: simple trinomials, complex trinomials, GCFs, and difference of squares. This is a GCF. So I'm going to take out a sine b, and I would get 2 cos b when I divided by sine b, and if I divide this by sine b, I get 1. So now, to solve, this would have to be 0, and this would have to be 1/2. Okay, in order to make that equation equal 0, this is either 0 or this is 1/2. Okay, so now what angle would you have here where your sine value is 0? So sine being 0 would be on your unit circle here. So since we're between 0 and 360, but looking at this interval, they're trying to trick you here, it doesn't include 360. It's less than 360. So you can state that it's b could equal 0 or 180. And then where's the cos 1/2 on your unit circle? So that'd be there. So this would be 60 degrees, and this would be 300 degrees on your unit circle. So b could also be 60 or 300. Okay, next one. 2 sine squared t equals 3 cos t. Okay, so now I am going to try to replace this, because there's obviously nothing you can replace for cos. So sine squared, so I'm going to go up here. I could replace sine squared with 1 minus cos squared. Just moving that around. So 2 replace with 1 minus cos squared. Okay, so now I'm going to distribute. And again, I would like to collect one side, make it a quadratic, factor solve. I'm going to move everything this way because when I factor, I like my squares positive. So 0 equals, so if I move this, it's 2 cos squared t plus 3 cos t And if I move that, it's minus 2. So factoring, you get a 2 cos squared and a 1 cos. Oops, sorry. 2 cos and a 1 cos makes your 2 cos squared. And then 2 and a 1 to make your 2. So where are you going to put your 2 and your 1? So I'm going to go 2 here, because that's going to make 4 and 1. So 4 positive, 1 negative. That works. So my solution would be for the t angle, where cos would be a half. And over here, cos of t would have to be negative 2. So here there would be no solution, because we don't have solutions for angles for cos and sine outside of negative 1 and 1. And where is cos 1/2? Oh, this seems consistent. Had this right there. And looking at our interval, we want a radian answer. So t would be pi over 3 or 5 pi over 3. Okay. Next, so here I look at tan squared and a secant. Okay, so we're going to look for something to replace. So I'm going to replace this tan squared right here. So tan squared would be secant squared minus 1. So I'm going to take that and replace that for tan squared. So 2 bracket. Okay, so there's my replacement of a trig identity. Distribute. Collect to one side. So I'm going to move that over. Factoring. This is almost the same factoring as the last one, except for the negative. So 2 secant and secant. And I'm going to use my 2 and 1. Okay, so now secant t would have to be negative 1/2, and secant t would have to be positive 2. Okay, so we don't solve for secant though. So what is secant the reciprocal of? It would be cos. So I can rewrite this as cos of the angle would have to be negative 2. Cos of the angle would have to be 1/2. Now this, there'd be no solution for. And this, where's cos 1/2? Well, same one we had before. But looking at my question, it says solve for all. So then I would say this angle or any revolution of that angle. So you could be there, or the next revolution of it, the next revolution of it. Or you could be here and the next revolution of it. So that's the answer for t. Okay, so just to recap how to solve this in radians for those, so in case you run into one of these. So how do you solve for the angle if sine of the angle is negative 1/3? And I want your answer in radians. So this is obviously not on the unit circle. So how do you do this? Okay, so first of all, remembering your Azteca quadrants. So sine of the angle is negative. So my angle would be in the bottom 2 quadrants. Okay, then you go into your calculator and you make sure that when you're doing this that you have radians for your mode, and you're going to go second sine of 1/3. Okay, you do not type the negative in because you're applying the negative into the location of the angle. So 0.3398. So that's how many radians you are off of this line. So remembering this line, how many radians is it? It's pi. So I'm going to add pi and that together. So here your angle is 3.481 radians. And this would be 2 pi, so you are less than that, 2 pi. So 2 pi minus 0.3398. And so that answer is 5.943.